Hello friends, welcome to my channel. In this lecture, I am going to solve some numericals based on the first law of thermodynamics, and I have chosen two books from which I am going to solve some problems. That is, first one is p.k.Nag's Engineering Thermodynamics, and second one is Cengel and Michael Bole's the Thermodynamics and Engineering Approach. So from both books, some problems will be solved. The first problem is from p.k.Nag's book. Before starting, I must say one thing to all of you. Please do subscribe to this channel and of course like it and share it to your friends. You see, the first question is like this. In a cyclic process, heat transfers are like this: 14.7 minus 25.2 minus 3.56 kilojoule and 31.5 kilojoule. What is the net work for this cyclic process? First law equation for any cycle is sigma q cycle is equal to sigma w cycle, or net heat transfer for a cycle is equal to net work transfer for a cycle. So since all the heat interactions that takes place for the cycle are given in the question, we can easily find out what will be the net work transfer, because we know that for a cyclic process net work transfer is equal to net heat transfer. So since all the heat interactions are given, we can find out net heat transfer, and that will be the net work transfer for the cycle as well. So net work will be net heat. So net heat is nothing but equal to summation of all these heat interactions, that is plus 14.7 kilojoule. Plus, in terms of heat interaction, means when heat is added to the system it is positive, and when heat is removed from the system it is negative. You see, if we add all these numerical values of heat interactions, it will be 14.7 plus minus 25.2 plus minus 3.56 plus 31.5 kilojoule. Of course, all these interactions are in the units of kilojoule. So it will be 14.7 plus there are two plus heat interactions. That means two heat interactions are from surrounding to system, and two heat interactions are away from the system towards surroundings. That's why the minus signs are there. So this is minus 25.2 kilojoule and minus 3.56 kilojoule. So 46.2 kilojoule minus 25.2 plus 3.56, and when it added it gives rise to 28.76 kilojoule. So 46.2 kilojoule minus 28.76 kilojoule, it results in plus 17.44 kilojoule. So this is net heat interaction as well as the net work interaction. Since according to first law, whenever a thermodynamic system undergoes a cycle, all the energy transfers across the system boundaries is zero. No energy enters in, no energy leaves, because so whatever energy enters must equal to the amount of energy that leaves the system. So that's why we derived the equation, that is for first law is sigma q cycle is equal to sigma w cycle, and that is, in other words, we can say net heat transfer for a cycle is equal to net work transfer, and heat interactions are given, we have to find out net work. So obviously if we find out the net heat interactions, heat interaction is same as summation of all those heat interactions for a system. So summation of heat interactions results in 17.44. So that will be the net work transfer for this cyclic process. And the second question is like this. You see, a slow chemical reaction takes place in a fluid at the constant pressure of 0.1 megapascal. So the process takes place at constant pressure, the chemical reaction. The fluid is surrounded by a perfect heat insulator during the reaction, which begins at state 1 and ends at state 2. During the chemical reaction, what happens? There is no heat transfer from the fluid to the surrounding. Neither from the fluid to the surroundings nor from surrounding to fluid, since there is an insulation. So no heat interaction can take place between the fluid and its surroundings, and the insulation is then removed. When the fluid travels from state 1 to state 2, there is no heat flow that takes place. And when the fluid moves from state 2 to state 3, what happens? The insulation is removed. Then heat flow may take place. And at that time, what happens? 105 kilojoule of heat flow to the surroundings as fluid goes to state 3. When the fluid goes from state 2 to state 3, 105 kilojoule of heat flows to the surroundings. That is negative heat interactions. When the heat is removed from system to surroundings, it is taken to be negative. So as the fluid moves from state 2 to state 3, heat interaction is minus 105 kilojoule. And Q12 is equal to 0. When the system travels from state 1 to state 2, there is insulation, so there is heat interaction is 0. The following data are observed for fluids at states 1, 2 and 3. For state 1, volume of the fluid was 0.003 meter cube and temperature was 20 degrees Celsius. And state 2, the volume increases to 0.3 meter cube and temperature increases to 370 degrees Celsius. And when the fluid moves to state 3, the volume is 0.06 meter cube and temperature is again 20 degrees Celsius. So what we are required to find out is, for the fluid system, calculate E2 and E3. You know, energy is a thermodynamic property. For every state, energy will have some numerical values for every thermodynamic system. So for every state there will be different values, because the properties are state variables of the system. So if U1 is given an arbitrary value or a standard value of 0, then what will be E2, or energy of the system at state 2, and energy of the E3. E2 means energy of the system or energy of the fluid in this case, in which chemical reaction takes place at state 2, and energy of the fluid at state 3. If it is given that E1 is equal to 0, E1, energy of the fluid at state 1, is given to be 0. You know, we can use either E in minus E out is equal to delta E equation, or directly this equation can be also used. You know, Q is equal to delta E plus W. Q is heat flow into the system, and W is the work done by the system, and delta E is the increase in energy, or E2 minus E1 for this case. When the system or fluid travels from state 1 to state 2, this will be Q12 is equal to delta E plus W12. Since heat and work are path functions, they are inexact differentials, so they are written like this: Q12. We cannot write Q2 minus Q1, but we can write E2 minus E1, because energy is a property of system. So Q12 is equal to delta E. Q12 means heat interaction when the system, or in this case fluid, travels from state 1 to state 2. And W12 is the work interaction when the fluid travels from state 1 to state 2. Here the pressure remains constant and the volume changes. Only work that is present is boundary work. There is no other work. There is no mention of any other work in this question. So P V2 minus V1. So that is equal to Q12. Again it is 0 in this case, because there is an insulation in the question. It is given that perfect heat insulator during the reaction which begins at state 1 and ends at state 2. First we will find out for this process Q, for the process 1 2, then we will go to 2 3. So Q12 will be 0. Q12 will be 0. Since there is an insulation, so Q12 will be 0. Q12 will be 0, and this is equal to E2 minus 0. E1 is your 0, value of E1 is 0. So E2 minus 0 plus pressure is given to be, pressure is 0.1 megapascal. Pressure is 0.1 megapascal. So 0.1 megapascal means 0.1 megapascal means 0.1 into 1000 kilopascal, because 1 megapascal is 10 to the power 6 pascal, or 10 to the power 3 kilopascal, or 1000 kilopascal. So since pressure is at constant at 0.1 megapascal means 0.1 into 1000 kilopascal into volume at state 2 here is 0.3. Volume here is state 2 is 0.3 and state 1 is 0.003. So that's why that will be 0.3 minus 0.003. That is equal to E2 plus 100.1 multiplied by 1000 produces 100 kilopascal into 0.297 meter cube. That is equal to E2 plus 29.7 kilojoule. Kilopascal multiplied by meter cube. Kilojoule. E2 plus 29.7 kilojoule is equal to 0. So E2 will be obviously minus 29.7 kilojoule. Why heat interaction is 0? Because there is a insulator. So E2 we calculated to be minus 29.7 kilojoule. Minus 29.7 kilojoule. So what will be the energy at state 3? Energy at state 3. Energy at state 3, how to calculate the energy at state 3. So energy at state 3 is, suppose we will consider the process 2-3. You see Q23, the equation is Q23, Q equal to delta E plus W, delta E plus W, W23. This is the equation where Q23 is the heat added to the fluid during that process 2-3 and work W23 is the work done by the fluid during that process 2 when the fluid travels from state 2 to state 3. So Q23 is given in the question that the insulation is then removed and 105 kilojoule of heat flows to the surroundings. That means Q23 will be minus 105 kilojoule. Since heat is removed from the fluid to the surroundings, it will minus 105 kilojoule. So E delta E during that process will be E3 minus E2. Simply when the system travels from state 2 to 3 means change in energy will be E3 minus E2 plus W23. You see throughout the process pressure remains constant. So P multiplied by V3 minus V2 is equal to E3 we are required to find out. E2 we just found out and E2 came out to be minus 29.7 kilojoule plus pressure is 0.1 megapascal. 0.1 megapascal means 0.1 multiplied by 1000 kilopascal into V3. V3 is given to be 0.06 meter cube. V2 is 0.3 meter cube. So V3 minus V2. 0.06 minus 0.3 meter cube. 0.06 minus 0.3 meter cube. So this is equal to E3 plus 29.7 kilojoule plus 100 multiplied by minus 0.24. So this is kilojoule. Since kilopascal multiplied by meter cube, it is kilojoule is equal to E3 plus 29.7 kilojoule minus 24 kilojoule. E3 E3 plus 5.7 kilojoule. Hence, we are required to find out E3 is equal to minus 10, since minus 105 kilojoule is equal to E3 plus 5.7 kilojoule. So, E3 will be minus 105 minus 5.7 kilojoule. This is equal to minus 7 kilojoule. In fact, energy of the system decreases during the process. Energy of the system decreases. So this is E3, and you see E2 we just found out. E2 is minus 29.7. E2 is minus 29.7 and E3 is minus 110.7 kilojoule. So next problem is from Cengel and Bole's book. You see, this is the problem. You see, water is being heated in a closed pan on top of a range while being stirred by a paddle wheel. During the process, 30 kilojoule of heat is transferred to the water and 5 kilojoule of heat is lost to the surrounding air. The paddle wheel work amounts to 500 Newton meter. Determine the final energy of the system if its initial energy is 12.5 kilojoule. So here water is being heated in a closed pan. So that means it is a closed system, and during the process 30 kilojoule of heat is transferred to the water. This is 30 kilojoule. 30 kilojoule water is being heated in a closed pan. So 30 kilojoule of heat is 30 kilojoule of heat. This is heat is given to the system, and a paddle wheel work is given into the system. Always paddle wheel work is a work which is done on this system. So for the calculation purpose, when there is a paddle wheel work, you should take it a negative sign before the paddle wheel work, because that is a work done on the system. So here the paddle wheel work is input into the system, and it is around paddle wheel work. Paddle wheel work is 500 Newton into meter. That is 1 Newton into 1 meter is joule. 500 Newton meter results in 500 joule. 500 joule, and it amounts to 0.5 kilojoule. 0.5 kilojoule. This is paddle wheel work. This is paddle wheel work, and then what happens? 5 kilojoule of heat is lost to the surrounding air. So there are three values, three interactions. That is, one is 30 kilojoule of heat is transferred to the water, then 5 kilojoule of heat is lost to the surrounding air here, and paddle wheel work that is given into the system is 500 Newton meter. So find out the final energy of the system if its initial energy is given. This is initial energy. In fact, there are two heat interactions and one work interaction that takes place. Two heat interaction, 30 kilojoule of heat is supplied to the water, and after water gets heated, it transmits around transfers 5 kilojoule of heat to the surrounding air. So we have to apply, find out the final energy. What happens, whether the energy increases or decreases, energy of water. What happens to the energy of the system? So we may apply the energy balance equation, which is nothing but E in minus E out is equal to delta E. which we have studied, that is energy balance equation. E in minus E out is equal to delta E, which is nothing but the change in energy of the system when the system undergoes a process. Delta E is equal to E2 minus E1. E2 is the energy of water at state 2 and E1 is the energy of water at state 1. So E in is the energy summation of all the energy interaction that takes place when summation of all energy that enters into water, and summation of E out is summation of energy that leaves the system or leaves water. So E in is your 30 kilojoule of heat. 30 kilojoule of heat. 30 kilojoule of heat, but this paddle wheel work is an energy input to the system. Since work is done on the system, when work is done, then arrow sign is towards the system. That means that is a energy into the system or input to the system. So this is also an energy in, that will come under the energy that enters into the system. And this is 30 kilojoule of heat enters the system, and again plus point that 500 Newton meter is equal to 0.5 kilojoule. So 30 kilojoule plus 0.5 kilojoule. This is your E in. This is your E in. And E out is this energy. This energy is the only energy that leaves the system during the process, and it amounts to 5 kilojoule. So E out is 5 kilojoule is equal to E2. E2 is the final energy of the system. We are required to find out E2 minus E1, and E1 is given to be 12.5 kilojoule. The initial energy of the system is 12.5 kilojoule. So E2 minus 12.5 kilojoule. So this becomes, from this what we find is 30 plus 0.5, 30.5 kilojoule minus 5 kilojoule is equal to E2 minus 12.5 kilojoule or 25.5 kilojoule is equal to E2 minus 12.5 kilojoule. E2 will be 25.5 plus 12.5 kilojoule. That is equal to 38 kilojoule. So energy of system or energy of water will be 38 kilojoule if its initial energy is 12.5 kilojoule. That means the energy of the water increases because the net energy is there. Net positive energy is there that enters the system, and that goes on to increase the energy, because here the net energy will be, energy input is 30.5 and that leaves the system is 5 kilojoule. So that net energy that enters into the system is 25.5 kilojoule, which goes on to be stored by the system. So this increases the internal energy. Initial energy was 12.5. So this net energy that will be added to the system will increase the energy of water to 38 kilojoule. So this is final energy. So next question is like this: air is contained in a variable load piston cylinder device equipped with a paddle wheel. Again here there is a paddle wheel also. Initially air is at 400 kilopascal and 17 degrees Celsius. Air inside the cylinder is initially at 400 kilopascal and 17 degrees Celsius. The paddle wheel is now turned by an external electric motor until 75 kilojoule per kg of work has been transferred to air. So always paddle wheel work is a work input to the system. That means here the paddle wheel work, in fact it is given in terms of unit mass. So paddle wheel work, this is the paddle wheel work is given to be 75 kilojoule per kg. This is a work input, and then during this process heat is transferred to maintain a constant air temperature while allowing the gas volume to triple. When work is done on the system at the same time, this is the steering work or paddle wheel work that is given to the system, and the system expands with its volume becoming 3 times that of initial volume. When work is supplied and at the same time some heat is also supplied, both these are energy entering the system, and at the same time air just expands, some PdV work is done, and whatever volume is inside this at state 1, it becomes 3 times when these energy interactions take place, or when these two energy enters the system. So we can easily apply energy balance. You are required to find out amount of heat transfer. What is this value of Q? So that this air would expand to the 3 times its initial volume. So some work will be done. You see, in every process that a closed system undergoes, energy balance equation holds good. You see, E in minus E out, this is the energy balance equation, is equal to delta E. This is a stationary system, this is not moving. Delta E is the summation of delta EK plus delta EP plus delta U. For a stationary system, these two terms are 0. So in this case also this is 0. So delta E is same as delta U. So energy balance equation I can write like this: E in minus E out equal to delta U. For any ideal gas, U is always a function of temperature. According to Joule's law, U is a function of U for an ideal gas. U for an ideal gas is a function of temperature. Since it is given that heat is transferred to maintain a constant air temperature, so temperature remains constant, and so since U is a function of temperature and the temperature remains constant, that means U is constant. When U is constant, delta U becomes 0. Since during this whole process, temperature remains constant, so that's why U being a function of temperature, delta U will be 0. So energy balance equation will now reduces to E in minus E out is equal to 0. And you see, E in is here, in this case, E in is steering work or shaft work, that is paddle wheel work, shaft work, paddle wheel work. Paddle wheel work input is given to be 75 kilojoule per kg. So 75 kilojoule per kg, and again this heat is also input to the system. So that is Q, 75 kilojoule per kg plus Q is, and what is the energy moving out of the system? This work that is done by the system. This work that is, when the system expands, means work is done by the system. And in this case, this is an isothermal PdV work. PdV work for isothermal process will be PV ln V2 by V1. During the process 1, 2, this happens. So P1 V1 ln V2 by V1 is the PdV work during an isothermal process or constant temperature process. So this case P1 V1 is for an ideal gas is RT1 ln V2 by V1 volume. Since volume becomes 3 times that of initial volume, this ratio becomes 3. Final volume becomes 3 times of initial volume. So V2 by V1 will be 3. That is equal to, R for air is 0.287 and absolute temperature is 290. 17 degrees Celsius is equivalent to 290 ln 3, and that is equal to 91.437 kilojoule per kg. Since E in minus E out is equal to 0 means E in is equal to E out. E in minus E out is equal to 0 implies E in energy in is equal to energy out. So that's equation we applied. Energy in is nothing but this pedal wheel work, and this is pedal wheel work. And this is heat flow that takes place, and that enters the system. So 75 plus Q is equal to this much. That means Q, if you find out this minus 75, that is 16.4 kilojoule per kg.